In this video, I am going to introduce you to the idea of differentiation rules. So let's talk about differentiation rules. So the very first rule that we want to talk about is, a constant rule. Constant rule. Alright, so what I'm going to do, I'm going to consider a constant. So let C is a constant, then d by dx of a constant is is 0. And in this case, my constant is C, so I will write d by dx of C is 0. Now, let's consider an example. So my example is find d by dx of 7. So as you can see, 7 is a constant because 7 is a fixed number. So d by dx of 7 will be what? 0. Now let's consider another example. And my example is d by dx of constant k. So if k is a constant, then d by dx of k is 0. Now, let's talk about our second rule, and my second rule is power rule. So the power rule is basically d by dx of x to the power n is n x to the power n minus 1, where n is what? N is any real number. Right? Now let's consider an example. So example is find d by dx of x to the power 5. So if you look at the rule for n, what do I have? 5. So my n is 5, and if I'm using the rule, I will write 5 times x to the power 5 minus 1. And 5 minus 1 is what? 4. So I will write 5 x to the power 4. Which means what? Which means that d by dx of x to the power 5 is 5 x to the power 4. Right? Now let's consider another example. So my next example is find d by dx of x cubed plus x to the power 4. Right? So what I'm going to do, I'm going to distribute the d by dx inside, and if I do that, I will write this one as d by dx of x cubed plus d by dx of x to the power 4, right? Now let's use the power rule. So if you look at the first expression, I have x to the power 3. So my n is basically what? 3. So if I use the power rule, which is right here, I will write this one as 3 x to the power n minus 1. So I have 3 minus 1 plus my second term is x to the power 4. And if I use the power rule, my n is 4 in this case. So I will write 4 times x to the power 4 minus 1. Now let's simplify further, and if we do that, we will have 3, and x to the power 3 minus 1 is what? X squared plus 4 x to the power 4 minus 1 is 3, right? So my differentiation will be 3x squared plus 4x to the power 3. Now let's consider another example. So my next example is, let's find dy dx of x to the power 1. What will be the differentiation? So the differentiation will be, my n is 1, so I will write 1 times x to the power 1 minus 1, because my formula for, or I should say my rule for the differentiation of the power rule is n x to the power n minus 1, and my n is 1. So I will write 1 times 1 minus 1, and 1 minus 1 is what? 0. So I will write 1 times x to the power 0, and x to the power 0 is what? 1. So I will write 1 times 1, which is 1. So dy dx of x is 1, right? Now let's consider one more example. So my example is, find the dy dx of 1 over x, right? Now in order to find the differentiation of 1 over x, we need to convert 1 over x in terms of this expression. So what I'm going to do, I'm going to take this x to the numerator, and if I take this x to the numerator, I will have dy dx of x to the power negative 1. Now as we can see, my n is negative 1. So I'm going to write this one as negative 1 times x to the power negative 1, this is my n, minus 1. Let's simplify further, and if I do that, I have negative 1 times x to the power negative 1 minus negative 1 is negative 2. So let's simplify further, and if I do that, I will take this x to the power negative 2 to the denominator, because I don't want to leave my negative exponent like that. So if I do that, I have negative 1 times 1 over x squared. Let's simplify further, and if I do that, I have negative 1 over x squared, because negative 1 times 1 is negative 1 over x squared. So dy dx of 1 over x is negative 1 over x squared. And this is how we will use the constant rule and the power rule to find the differentiation of the given function.